hello, namaste, vanakkam, adab, and welcome back to my channel. If you're new, please do subscribe and like so that it cheers me up so that I can make many more videos actively. So in this video, we are going to discuss about this germ layer derivatives and also about congenital malformations of the nervous system. So we are going to focus mainly on ectoderm, and mesoderm and endoderm will discuss as a part of the revision. I already did this germ layer derivatives in embryology, and let's repeat it again in detail. So basically ectoderm, it consists of surface ectoderm and also Neuro Ectoderm. And these surface ectoderm consist of epidermis, skin, hair, nails, and inner ear, external ear. External ear is the remnant of the pharyngeal cleft. Actually, we discussed about this pharyngeal cleft, pharyngeal pouches, and pharyngeal cartilage. So next, enamel of teeth, and also lens of eye, and the most important is anterior pituitary. It is derived from the surface ectoderm. So anterior pituitary is here, and where is posterior pituitary? We'll come across that later. And this anterior pituitary famous outgrowth is rat case pouch. As we know, if this rat case pouch persists, we get a disease called as craniopharyngioma. Rat case pouch, if this persists, we get craniopharyngioma. This is important. And also next one is parotid glands. This is about the surface ectoderm. And let's talk about this Neuro Ectoderm. This Neuro Ectoderm again has neural tube and neural crust. This neural tube is CNS, we know about this, and neural tube is PNS. Just remember this as it is. So neural tube, it has central nervous system as named, and also retina and optic nerve. This optic nerve is special because optic nerve is not a nerve, it is a tract because it is surrounded by completely oligodendrocytes. So that is why optic nerve is not a nerve, it is a tract. So remember that. And again, pineal gland, and also neurohypophysis, that is posterior pituitary. And next one is astrocytes and oligodendrocytes, as we know that I told you here in optic nerve. Oligodendrocyte, see this myelinates the CNS. And next one is neural crust. In this neural crust, we'll be having adrenal medulla. I know that I already repeated that this adrenal medulla because this is famous for chromaffin cells which migrate to adrenal medulla to form postganglionic autonomous neurons. I hope you'll understand, or at least you are listening so that you can note it down. And next, ganglia. This has sensory and autonomous. All sensory ganglia come under this neural crust except for one, axon of this optic nerve, as it is completely myelinated by this oligodendrocytes of the CNS. And next one is pigment cells. Where is the pigment cells are present? Pigment cells are present in skin, we know that, which are melanocytes. But in which part? That is basal layer, famous basal layer, which is stratum basalis. And also Schwann cells. Schwann cells causes schwannoma. I already told this. But schwannoma, this is most common type. Schwannoma. What is most common type? And where it occurs? Most commonly it occurs in the cranial nerve 8, that is vestibulocochlear nerve. So we can guess this schwannoma, that is vestibulocochlear. So acoustic schwannoma. This is very important. It occurs at a cerebellopontine angle. So what is this cerebellopontine angle? This is nothing but cerebellum above and pons below. And this is also seen in NF1, which is neurofibromastosis 1. And next thing is it also has meninges. The meninges are pia and arachnoid matter. So where is dura? Dura is in coming. We'll discuss about that. So, and also pharyngeal arch cartilage, which causes first arch syndrome. And also this pharyngeal arch cartilage is responsible for the muscles of mandible and also neck muscles. Mandible and neck, cartilages, not muscles. And next we can find odontoblasts and parafollicular cells, which produces calcitonin, and also articopulmonary septum, which is mainly due to tetralogy of Fallot. This is also very important. And endocardial Cushing's, which is famously seen in Down syndrome. So that is about this ectoderm. We'll come across mesoderm and endoderm in a minute. So now, mesoderm. Mesoderm means muscle, that is vascular systems, everything. Vascular system means cardiac, smooth, skeletal, and connective tissues, and all serous membrane, and also bone and cartilage, and blood, lymph, cardiovascular organs, and also adrenal cortex is derived here, and adrenal medulla in Neuro Ectoderm, as I told. And next, gonads and internal reproductive organs, and spleen, and kidney, and ureter, and also dura mater. And next one is, it is endoderm. These endoderm forms epithelial parts of tonsils, thymus, pharynx, larynx, trachea, bronchi, lungs, and urinary bladder. You can see ureter here and urinary bladder here, and also urethra and tympanic cavity, auditory tube, gastrointestinal tract, that is foregut, midgut, and hindgut. And this also forms the parenchyma of liver, pancreas, tonsils, as I told here also, and thyroid gland, parathyroid gland, glands of gastrointestinal tract, and submandibular, and also sublingual. So this is about this germ layers. Now let's discuss about this congenital malformations of the nervous system. So this has 6 diseases, that is anencephaly, spina bifida, which is further classified into 4 types, and also Arnold Chiari and Dandy Walker and Hydrocephalus and Pressencephaly. So coming to anencephaly, we discussed about this anencephaly and polyhydramnions previously, and now we're going to discuss this. What is anencephaly? Anencephaly is nothing but the failure of rostral or anterior is nothing but rostral top neuropore to close. So in this case we can see brain does not develop as anterior or rostral forms this brain and all, so it is obviously incompatible with life. And the classic markers here we can see is, what are markers? That is ACHE, acetylcholinesterase, which is related to open neural tube defects, and also AFP, which is alpha fetoproteins, which are related to body wall, and also polyhydramnions. What is polyhydramnios actually? Polyhydramnios is nothing but increase of the amniotic fluid. So why it occurs here? Because there is no mechanism, there is no neural mechanism to reduce this amniotic fluid. So this increases in building of polyhydramnios, results in anencephaly. And next, spina bifida. This is having actually 4 types. We'll classify it A, B, C, D. A, B, C, D. What is this? First one is spina bifida occulta, and next spina bifida meningiomysia, and next one is spina bifida meningiomyosia, and next one is spina bifida myelosclerosis. So let's discuss this first one first, because this is most severe and also very rare, because in this spinal cord is seen externally. So if the spinal cord is seen externally, what are the markers we can see here? That is, as this is open neural defect, we'll get ACHE, and also this is body wall defect, so we'll get AFP. And next one is these 3. What are these 3, and why is this 4th one? These 3 have a similarity, because these are the true forms of spina bifida, because they don't have any open neural tube defects. So actually what a newly formed vertebrae should do, this rough figure, okay, this should do the newly formed spinal cord, actually it should induce the bone to grow around it, that is, it should form vertebral arch. But in this 3, what happens is this partial formation of vertebral arch takes place, and these laminae doesn't fuse properly to form this spinous process. So we can see this spinous process is missing in lumbar regions. And so if we discuss about this, if ectoderm, that is skin, grows over the site of the neurulation, and spinal cord is normal and is surrounded by CSF. So what is this case? This is nothing but Spina Bifida occulta. What is occulta? Occulta means hidden. What happens here? This is failure to induce the bone growth around the spinal cord. This is mildest form. So there is no increase in AFP because this is not body wall defect, and also this is asymptomatic. So if there is no AFP, no SAH, no polyomyos, how can we identify this? There is only one classic marker which is important, that is just we can see only some tuft of hair here, and also this is most commonly missed in ultrasounds. And next, coming to B and C. B and C have some common, that is Meningiocele and Meningiomyosial. Seal is nothing but cyst. What happens here? The cyst protrudes through the defect, which is lined by dura and arachnoid. So coming to Spina Bifida, Meningiomyosial, what happens here? In newborns, this stretches to lumbar sacral nerves, so that we can see some sensory loss or weakness here. This is actually Spina Bifida Meningiomyosial. We can see meninges and spinal cord protrude through this vertebral defect, which is also seen in Arnold Chiari type 2. We'll discuss about this later. And what is this classic marker here? There is increase in AFP because it forms a cyst, which is body wall defect. So there is increase in AFP. And also what happens is in Meningocele and Meningiomyosial, this ectoderm does not close properly at the site of neurulation. So what is leaking out of amniotic fluid? Most of you think that as cerebrospinal fluid, but it is not, because it is nicely protected by this dura and arachnoid matter. But we can see AFP leaking out in this. And next one is Spina Bifida Meningiomyosial. As this name indicates, Meningocele. Meninges protrude through this vertebral defect, and increase in AFP we can see here. And next one is Arnold Chiari type 1 and type 2. This has two types actually. What is this Arnold Chiari actually? This is downward herniation of different parts of the brain. That is, in type 1, it is cerebellar tonsils through foramen magnum. So in type 2, it is cerebellar vermis. Actually, this type 1 is asymptomatic in children, and it is also most common. We can see this associated with syringomyelia. What is syringomyelia? This is nothing but the enlargement of the central canal of the spinal cord. And next, type 2, this is downward displacement of the cerebral vermis, which is symptomatic. So this downward displacement of this cerebellar vermis causes the compression of the fourth ventricle, which causes obstruction or non-communicating hydrocephalus. So this is also associated with the lumbar Meningiomiosele. I told you now, Spina Bifida Meningiomiosele, that is associated with the type 2 Arnold Chiari. And next, Dandy Walker syndrome. Dandy Walker, malformation, maybe, whatever. So this is basically congenital absence of one or more foramina, that is failure of foramina lasca and marginae to open. So this causes of the dilation of fourth ventricle, which causes hydrocephalus, obviously. This, and also agenesis of cerebellar vermis and splenium of corpus callosum is seen here. And next one is hydrocephalus. What is hydrocephalus? Hydro, water, cephalus, head. We can see this by its name. That is, this is most often caused by the stenosis of cerebral aqueduct. So this results in the obstructive flow of CSF, so that CSF accumulates in ventricles and also in subarachnoid space. So this increases head circumferences. And next one is hollow pressencephaly. That is incomplete separation of the cerebral hemispheres. One ventricle in telencephalon. We know that telencephalon has two ventricles. And also this is seen in Patau syndrome, which is trisomy 13. If you have any queries or doubts related to this or any improvements, you can just text me in Insta or mail me. I'll definitely respond. If you have any queries, sure, I'm available. So please do like, subscribe this video so that it helps me a lot. And thank you. See you in the next video.